Hello guys, welcome back at another video on our channel. So in our today's video guys, I'm gonna explain to you all Gauss-Jordan method with some of the examples. In my previous lecture, I explained to you all complete the standard procedure. How can we follow the steps for finding the Gauss-Jordan for the inverse of matrix using Gauss-Jordan method. Okay, so in our today's video guys, I'm gonna explain to you all one of the important example repeated mostly, okay, in exam. So I'm gonna explain this example for finding the inverse, okay, for the matrix A. So we are having matrix A. Now we want the inverse of a matrix A, okay, using Gauss-Jordan method. Okay, now let's follow the steps that I have explained already. Okay, see that if the matrix is a 3 by 3, build the identity matrix for 3 by 3. Okay, so I'm solving this example. Let's get dive into our today's lecture guys. We go for the solution. Okay, so if A matrix is a 3 by 3, so we can write the matrix identity which is also 3 by 3. Okay, so how can we write 1 0 0 0 1 0 0 0 1? Okay, this one is the 3 by 3 matrix. Okay, so we are having matrix A and identity matrix as a 3 by 3. Okay, what the Gauss-Jordan method says that try convert given identity matrix and a given matrix that we want the inverse into similar form of augmented matrix. Okay, similar form of augmented matrix we write as A over B, A over identity. Okay, this one is the next step. Okay, so we try convert given A matrix A and identity matrix in the form of a similar augmented form. Okay, yes, and then we go for the letter row transformation. Okay, yes, so let's first of all convert the matrix into the augmented form. Okay, 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4. Okay, after that this slash it comes here. Okay, this is the slash. Okay, actually consider this is not the square bracket guys. Okay, this is only the slash. After that we have to add identity matrix of a 3 by 3. 1, add this one 0 0 0 1 0 0 0 1. Okay, this is the augmented form for matrix A and identity matrix. Okay, we combine this one together. So what is the next step? We have to apply row transformation to given matrix. Okay, so obviously this matrix is having 3 rows and 6 columns. Okay, so apply row transformation to this matrix in order to get A matrix into the identity matrix. Okay, so we have to convert, basically we have to convert this matrix into the identity matrix. Okay, and this one we do not need to go for anything here. Okay, the operation which you are going to follow for the matrix A, it will remain same for this also, because this comes under one single matrix. Okay, yes. Now first of all, always remember that while applying row transformation, take first element 1, then second one 0, third one 0. After that go to the second element 1, then 0, then 0, then after that last element 1, then 0, then 0. Okay, so accordingly you have to find out the row transformation. So here guys, see that, be careful, we want first element as 1. Okay, but already one element is there, so we do not need to go for any changes, because our first task is that to get this element as 1, but actually we don't need, it is already there. Okay, so our next task is second element 0, third element 0. Okay, yes, so for making second element 0 you can do the operation on R2, which is R2 minus R1. Okay, that one is the first operation. Okay, so that I will get the element 0. Okay, and third I also want that 0. Okay, so what you can do, operation on R3, what is the operation on R3? R3 plus 2 times R1, so that one also will get 0. Okay, so what we are doing here in actual, we are operating R2 and R3 rows only. Okay, that means R1 row entire it will remain same. Okay, make sure that guys, I'm telling you all one more time, the operation which you follow for this row or this row, it remains same to this row. Okay, so this one is our entire single matrix, and then operate. Okay, yes, This one is our matrix, okay, which is for the 3 by 6. So make sure that the rows you are going to operate, keep it blank, and the remaining row you do not want to operate, keep it same. Okay, so we are taking operation on R2 and R3. So in actual we don't need to change anything on R1. Okay, R1 it remains same, 1 1 3 1 0 0. Okay, this R1 row it will remain same because operation only on R2 and R3. So what is the operation on R2? R2 minus R1. So 1 minus 1, 0, write down instead of R2. 3 minus 1, which is a 2. Minus 3, minus 3 minus 3. Okay, so it will goes to the minus 6. Okay, and 0, so similar operation to the next here. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. Okay, this is the entire operation on R2, which is the 0 to minus 6, minus 1, 1, 0. Okay, similarly operation on R3. What is the R3 plus 2 R1? Okay, R3, what is the third row? Minus 2, minus 4, minus 4, 0 0 1. Okay, this is a third row, R3. Okay, this is a R3 I have written. Okay, so what we are doing, we are adding 2 times R1 to it. Okay, that means multiply 2 to the R1. Okay, 2 times R1 and then add both of them. Okay, yes, so what I have done actually, this is the negative sign for 2. Okay, negative 2. Okay, this one is the R3 as it is. Okay, and 2 times R1, multiply R1 to 2, 2 2 6, 2 0 0, 2 2 6, 2, that means we are multiplying 2 to R1, 2 2 6, 2 0 0, 2 0 0. Okay, and we are adding both of them. Minus 2 plus 2, 0. Okay, write down here directly. Minus 4 plus 2. Okay, that means 2 minus 4, which is a minus 2. Minus 4 plus 6, 6 minus 4, which is a 2. Okay, again 0 plus 2, which is a 2. Again 0 plus 0, 0, and 1 plus 0, which is a 1. Okay, now see that guys, we are reducing our matrix. Okay, so which is a 0 minus 2. Okay, 0 minus 2, what we have here? So we got this matrix guys. Okay, so after operating these two operation R2 and R3, okay, so we got this one. So first 1, then 0, then 0. Our next target is, I want this 2 as a 1. Okay, I want this 2 to get converted into the 1. So what if I divide 2 throughout this matrix like a scalar multiplication? So I want to operate R2, which is a 1 by 2 is a scalar multiplied by R2. Okay, so obviously we'll get 1 here. Okay, it is not the big deal. Okay, so later on we want this one 0. Okay, yes, so can we combine the operations together? We add some more operations so that calculation will be easier for us. So you can divide 2 throughout this matrix, and again you can divide 2. So once we get 1 1 here, it is easy to calculate. Okay, so second operation we want on R3. Okay, so what operation can be possible? You can divide by 2. So 1 by 2 R3. Okay, so we are dividing by 2 to the R2 and R3. Okay, that means it is a 1 by 2 is a scalar multiplication. So you can multiply any constant to the any row or column. Okay, that is the standard operation. Okay, let's find out the resultant matrix. So operation it is only on R2 and R3. So we have to keep R1 as it is. Okay, so write down the matrix R1 as it is. Okay, what is the R1? 1 1 3 1 1 3 slash minus 1 0 0. Okay, this one is a 3 by 6 matrix. Okay, operation is only on R2 and R3. Okay, so what we are doing, we are multiplying scalar 1 by 2. So 0 1 minus 3, 0 2 divided by 2, which is a 1. Okay, and minus 6 divided by 2, which is a minus 3. After this minus 1 by 2, we are dividing again 2 here, 1 by 2, and 0 by 2 means 0. Okay, yes, so after this we on row R3 we are dividing by 2. Okay, 0 by 2, which is a 0, minus 2 by 2 which is a minus 1, and a 2 by 2 which is a 1, okay, and a 2 by 2 is also 1, 0 by 2 is a 0, and 1 by 2 is a 1 by 2, okay. Yes, now see that we got the 1 here, okay. It is very easy to get the 1 here. Now our next task is that to get the 0 here, 0, then here 0, okay. So easily we can add r1 and r3. Operation on r1 we needed. Now what is the operation on r1? R1 plus r3. So if you are adding 1 minus 1, it will be 0. But make sure that guys, we do not want to change that 1, okay. We are looking for identity matrix, so we do not want that 1 to be changed, okay, or the either remaining 2 element to be changed, okay. So keep them as it is, don't change anything, okay. Yes, so later on operation on r1, okay, so we'll get that one 0, okay. So can we combine more operation here? So we can add more operation, okay. So we are changing r1 row now, so we want the 0 again here, okay. Then next to operation, and we are adding one more operation, okay. So we want the operation on r3, that means this one is 0, means we want the operation on r3, okay. What is the possible operation? You can add r2 r3 plus r2, r3 plus r2, okay, r3 plus r2. So operation is only on r1 and r3. Keep r2 as it is, okay. Yes, we are keeping r2 as it is, okay. So 0 1 minus 3, this complete, okay. Minus 1 by 2, minus 1 by 2 0, minus 1 by 2 1 by 2 0, okay. Yes, this one is the r2 row as it is. We are not changing anything as we have operation on r1 and r3, okay. So what is the operation on r1? Okay, r1 plus r3, r1 plus r3, okay. 1 plus 0 which is a 1, operation on r1 now. 1 minus 1 0, 3 plus 1 4, 1 plus 1 2, 0 plus 0 0. We are adding r1 plus r3, 0 plus 1 by 2 1 by 2, okay. Yes, so again next operation on r3, r3 plus r2, okay. So r3 operation on r3, what is the r3 plus r2? 0 plus 0 0, minus 1 plus 1 0, 1 minus 3 minus 2, okay. Again 1 minus 1 by 2, okay, 1 minus 1 by 2 which is 1 by 2, 0 minus 1 by 2 minus 1 by 2, and 1 by 2 minus 0 1 by 2, okay. This is our resultant matrix, okay. Now next task, I want 1 here, okay. I want 1 here. So what the operation can be possible? I have to do operation on r3, okay. So which is a scalar we needed? Minus 1 by 2 multiplied by r3, okay. So if you multiply minus 1 by 2 into minus 2, we will get the 1 very easily, okay. So that one is easy to get the 1, okay. Yes, now next task, we want this 0 and this 0. So here we can write, okay. So first of all, go for the operation of this row, okay. So we write this one in the form of we are operating only r3, so keep r1 r2 as it is. 1 0 4, okay. 1 0 4 2 0 1 by 2, okay. Again 0 1 minus 3 minus 1 by 2 1 by 2 0. Operation only on r3, which is a multiplication of minus 1 by 2 into 0 0, minus 1 by 2 into 0 0, minus 1 by 2 into minus 2 which is a 1, minus 1 by 2 multiplied by 1 by 2, okay, minus 1 by 4. So multiplication of a two rational number, minus 1 by 2 into 1 by 2 minus 1 by 4, minus 1 by 2 into minus 1 by 2 plus 1 by 4, and minus 1 by 2 into 1 by 2 is minus 1 by 4, okay. So this is just multiplication of minus 1 by 2. We are not looking for the next matrix, okay. Our only task is that convert this matrix to the identity matrix, okay. So I got this one here, one here, one here. Our next task is to bring that 4 to the 0 and again minus 3 to the 0, okay. So what can I do? If I multiply, so see that I want this 0, so I can operate this element with this one, okay. So if you are going to operate this one, this will change this 0. So we do not want this 0, this one and this 0 to be changed, okay. So while operating this row, row or column, make sure that we do not have to change. We do not have to change these two columns, okay? So that don't go for the operation according to these elements, okay? So make sure that that 0 cannot change this 0, okay? And that one also cannot change this one. So what we do, we multiply 4 to the, we want the operation on R1, okay? We want the operation on R1, okay? What is the R1? R1, okay, R1 minus 4 times R1 minus 4 times R3. So what happened? 1 minus 0. 0 means 0, it will remain 0. 1 0 minus 0 and 4 minus 4, it will go to be the 0, okay? So we'll get that one 0. R1 minus 4 times R3, okay? Later on we want this minus 3 as a 0 also, okay? So what we do to get that 0? Okay, this operation is on R1, okay? So while operating the rows or column, make sure that the operation which you are following here, you don't have to include subsequently, okay? So if you are operating row R1, don't take it further, okay? So it will be the confusing for us, okay? Yes. So after this getting 0, we want this one, okay? So we do not include R1 to the next operation, okay? So I want minus 3 as a 0, okay? So how can we get minus 3 as a 0? So if that means we want the operation on R2, okay? Minus 3 as a 0 means operation on R2, okay? This one is second row. So what if I multiplied a third row to the 3 and if I add it to the second, so that one can give us the value easily, okay? So operation on R2, what is operation on R2? R2 plus 3 times R1, 3 times R3, okay? R2 plus 3 times R3, okay? So if you should multiply 3 here, 3 plus minus 3, it will be the 0, okay? So let's go for the R1 and R2. First of all, the rows which remain same don't change, okay? Do not supposed to change. So we write the row, they are not going to change, okay? So R1, R2, it will change. That means R3 remain as it is, 0, 0, 1, minus 1 by 4, 1 by 4 and minus 1 by 4. Okay, this one is the R3 row, it will remain same. Operation is only on R1 and R2, okay? Yes. So first of all, follow the operation on R1. R1, what R1 says that R1 minus 4 times R3, okay? What is the R1? 104, 104, 201 by 2, 201 by 2, okay? This one is the R1 row, okay? This one is the R1 row, okay? Minus 4 times R3, 0 into 4, 0, 0 into 4, 0, 1 into 4, 4, after this minus 1 by 4 into 4, okay, minus 1 by 4, we are multiplying R3 to the 4, okay, 4 into minus 1 by 4, which is a minus 1, 4 into 1 by 4, which is a 1, okay, 4 into 1 by 4 is 1, and a minus 1 by 4 into 4, which is a minus 1, okay, this is the operation 4 times R3, okay, this is the operation 4 times R3. So do that subtraction, 1 minus 0, operation on R1 only, guys, okay, 1 minus 0, 1, 0 minus 0, 0, 4 minus 4, 0, 2 minus 1, it is not like this, guys, 2 minus minus 1, okay, 1 minus 0, 0 minus 0, 4 minus 4, 2 minus minus 1, it will be 3, okay, 2 minus minus 1 means 2 plus 1, 3, 0 minus 1, which is minus 1, 1 by 2 minus minus 1, okay, 1 by 2 minus minus 1 means 1 by 2 plus 1, okay, which is 3 by 2, 2 ones are 2 plus 1, 3 by 2, okay. So I did the operation on R1, okay, that I got the result on 1 0 0 and later on this matrix, okay. Yes, so similarly I want the operation on R2 plus 3 times R3, okay, R2 plus 3 times R3, okay. So what is the row R2? 0 1 minus 3, 0 1 minus 3, minus 1 by 2, 1 by 2, 0, minus 1 by 2, 1 by 2, 0, okay. This one is R2, okay. So 3 times R3, if you multiply 3 to here, 0 0 3, 0 0 3, minus 3 by 4, 3 by 4, minus 3 by 4, minus 3 by 4, 3 by 4, minus 3 by 4, okay. So after multiplying 3 to the R3, okay, and add both of them, R2 plus 3 R3, R2 plus 3 R3, okay. So what is their addition? R2 plus 3RT, 0 plus 0, it remains 0. 1 plus 0, 1, minus 3 plus 3, 0. Okay, so see that we got the identity matrix. Okay, so next operation, minus 1 by 2 plus minus 3 by 2, minus 1 by 2 plus minus 3 by 2, it means minus 3 by 2, minus 1 by 2, minus 3 by 2. Okay, so take negative common, 1 plus 3, 3, 4 by 2 means it is a minus 2. Okay, so if you don't know how to calculate this one, first of all take the negative common, 1 by 2 plus 3 by 2. Okay, 1 by 2 plus 3 by 2, negative base same, take it once. Okay, minus 3 plus 1 by 2. Okay, that means 4 by 2, which is a minus 2. Okay, so we got the minus 2 over here. Okay, minus 1 by 2 plus minus 3 by 2. Okay, 1 by 2 plus 3 by 4. Okay, 1 by 2 plus 3 by 4. So how we write 1 by 2 plus 3 by 2? 4. We are adding 1 by 2 minus, this one is minus guys, 1 by 2 plus minus 3 by 4. So 1 by 2 minus 3 by 4. Okay, make the denominator same, 4 here, 2 here. Okay, 2 minus 3, minus 1 by 4. Okay, so we get the minus 1 by 4 and 0 plus, so 1 by 2 plus 3 by 4 is there guys, 1 by 2 plus, there is the addition. Okay, 2 plus 3, 5 by 4, which is the 5 by 4. So what we are doing guys, 1 by 2, this 1 by 2 plus 3 by 4. Okay, so 1 by 2 plus 3 by 4 means 2 by 4 plus 3 by 4. Okay, 2 plus 3, 5 by 4, which is a 5 by 4 here. Okay, which is a 5 by 4. Again 0 plus minus 3 by 4, which is a minus 3 by 4. Okay, so see that guys, we got the required answer. Okay, what is our required answer guys? You can see this matrix, augmented matrix, we converted into identity over A inverse. Identity over A inverse. You can see this identity over A inverse we converted. Okay, so identity over A inverse. So this one is the identity matrix and this one is the inverse for our given example. Okay, this one is the inverse for our given example. So what is the inverse matrix? Let me write it separately. 3 minus 1, 3 by 2, minus 2, 5 by 4, minus 3 by 4. Okay, minus 1 by 4, 1 by 4, minus 1 by 4. Okay, this one is a 3 by 3 inverse matrix. Okay, so the A inverse we have here. Okay, yes, I hope guys you all have understood entire my process of the solution. Nothing we have difficult here. Okay, so if anything calculation mistake like a plus minus, let me know in my channel guys. Okay, so I want you all to solve one of the example for your homework. Okay, so I hope you all have understood my entire process. Okay, for the solution. So if you want, you can refer this entire solution. Your question starts from here and this solution goes to all the way here, and after the next page this one is the solution. Okay, so take one of the example for your homework. So guys, here I'm having one of the example A as a 1 1 1 1 1 minus 1 1 minus 1 0 as a 3 by 3 matrix, and we want the inverse of a given matrix. Okay, using Gauss-Jordan method. This one is a compulsory example for you all. Okay, I want the answer of this matrix into my comment section. Okay, you can type directly as the element, what is the A11 for the A inverse, what is the A12 for the A inverse, and A33 for A inverse. Okay, give me the inverse in my comment section. Okay, I want you all to practice this one. Okay, so that one is for here for my today's lecture guys. I hope you all have understood my entire lecture. Even after, if you found anything difficult, confusing, let me know in my comment section. I will come up with the similar videos. Okay, so see you guys, we are going to continue in our next lecture. So thank you everyone.